All right, so get this. Have you ever noticed how some things just look right? Like they're perfectly balanced.
Yeah, like what?
Well, we're about to find out why because today we're diving deep into the world of symmetry. We're starting with a chapter from a geometry textbook.
Geometry textbook.
I know, right? But trust me, if this is going to be anything bid UT boring, we're talking about the kind of symmetry you see everywhere. Architecture, nature, even those patterns you see in like a sunflower.
Okay, I'm intrigued.
And get this, we'll even uncover the secret symmetrical talents of the alphabet.
The alphabet. You're kidding. What's so symmetrical about the alphabet?
I know, right? It's surprising. But that's what's so cool about symmetry. It's everywhere.
Well, and it's not just about aesthetics. It's actually a fundamental principle.
Yeah.
You're like woven into the fabric of the universe.
Whoa, the universe.
Yeah, think about it. The intricate dance of planets in our solar system, even like the formation of crystals, it's all about symmetry. It's this unseen force shaping our world.
Okay, I'm hooked. But before we get too cosmic, let's start with the basics. This textbook defines line symmetry, you ready for this, as the ability to fold a figure in half so that both sides match perfectly, like a mirror image.
Exactly. And that fold line, that's what we call the axis of symmetry. Think about a butterfly. That line right down the middle where the wings meet, that's the axis.
Oh, I see. Like with a beehive or a flower, you could draw a line right down the middle, and both sides are like mirror images.
Exactly. And you know what the textbook mentions is really cool activity you can do. Remember making paper snowflakes as kids? You fold the paper, cut out some shapes, and when you unfold it, bam, symmetry magic.
Oh, yeah. I used to love doing that.
It's a fun way to see how a mirror image on one side of a fold line creates a symmetrical design.
That's awesome. Speaking of shapes, the textbook then goes on about regular polygons. Those multi-sided figures with all equal sides and angles, triangles, squares, pentagons.
Right. Like, before we get all textbooky, imagine a pizza, a perfectly cut slice, of course. That's an equilateral triangle, right?
Mm.
Now, how many ways could you fold that pizza slice so both sides match perfectly?
Well, each fold would have to go through a point and cut the slice in half, so 3.
3. You got it. That's because an equilateral triangle, like your pizza slice, has 3 lines of symmetry. And get this, that principle applies to all regular polygons. The number of sides tells you the number of lines of symmetry.
So a square napkin would have 4 lines of symmetry. A pentagon-shaped building, 5. That's so cool.
Exactly. And you know what? Speaking of looking at things in new ways, let's move beyond folding and talk about what happens when we start spinning shapes.
Spinning shapes? I'm not sure I follow.
Well, there's this whole other type of symmetry we haven't even touched on yet. Rotational symmetry.
Rotational symmetry. Okay, gonna need you to break that down for me.
Okay, so picture this. The hands on a clock or the blades of a ceiling fan. They rotate around a central point, right?
Sure.
And at certain angles, they look the same as their original position.
Oh, I see. So instead of folding it in half, like with line symmetry, it's about how it looks when you spin it around.
Right. You got it. But, and this is important, it's not just randomly spinning. The textbook, it emphasizes this idea of order when we're talking about rotational symmetry.
Order. Okay.
Yeah, like how many times a shape looks the same as its starting position during a full rotation, a full 360 degrees.
So there's like a specific number of times it matches up in a full circle? Wild. What kind of order are we talking here? Like, give me an example.
All right, let's take a square. Easy to visualize, right? Imagine spinning it a full 360 degrees. It would look the same 4 times every 90 degrees.
So a square has a rotational symmetry order of 4.
You got it. The order 4. And just like line symmetry, we see this everywhere.
Really?
Oh, yeah. Think about a slice of orange. When you cut it crosswise, it often has rotational symmetry. Or those perfectly crafted road signs. Made to be recognizable from any direction, right?
It's true. A stop sign looks the same no matter how you're approaching it.
Exactly. And, that's important, right? It'd be super dangerous if a stop sign didn't have rotational symmetry. So symmetry, it's not just about aesthetics. It's functionality. It's safety, even. It's a crucial part of design.
Wow. Never thought about it that way. So you've got folding line symmetry and spinning rotational symmetry, but are there shapes that have both?
You're thinking about the mighty circle.
The circle. But a circle doesn't have any sides or angles. How can it be symmetrical?
That's the cool part. It goes beyond sides and angles. Imagine drawing a line, any line, right through the center of a circle.
Okay, yeah, I'm picturing it.
That line, it always divides the circle into 2 identical halves. So that means it has an infinite number of lines of symmetry. Any line through the center, same result.
Wow, that's incredible. So symmetrical no matter how you slice it. And since it's perfectly round, I'm guessing it also has infinite rotational symmetry. I mean, you can
Yeah.
spin it however much and it'll always look the same, right?
Exactly, you're on a roll. Circles, they're like the ultimate symmetry superstars. Throughout history, in all these different cultures, the circle has been seen as this symbol of perfection, of unity, even the divine.
It really makes you think about like all those times you've just doodled a circle, you know? Maybe tapping into some deeper universal principle without realizing it.
Right. And get this, even some letters of the alphabet, they have these hidden symmetrical talents too.
The alphabet, seriously.
Yeah. Think about the letter H. It has like vertical and horizontal lines of symmetry.
So you could fold it both ways, like a perfectly symmetrical sandwich?
Exactly. Or take the letters S or Z. They don't have line symmetry, but if you spin them 180 degrees,
Boom. They look identical. Rotational symmetry. Who knew the alphabet could be so geometrically interesting?
it really highlights something important. This chapter, it shows us that symmetry, it's not just some math concept. It's woven into how we communicate, the symbols we use, even the beauty we see around us.
So we're not just talking about shapes on paper. It's deeper than that.
Way deeper.
So much more to it. It makes you really appreciate the elegance of like design and nature in a whole new light.
It really does.
We've talked about line symmetry, rotational symmetry, seen how these concepts are everywhere, from pizza slices to, get this, the alphabet. But what does it all mean? What's the takeaway for our listeners who might be thinking, okay, that's cool and all, but why should I care about symmetry? Like, beyond passing my next geometry quiz.
Well, I think that's the beauty of it.
Yeah.
When we explore these concepts, it's like seeing the world with new eyes. You start noticing these patterns, these connections you never would have before.
Totally. It's like suddenly you can see the matrix or something.
Yeah, exactly. And symmetry, it's like this hidden code, like a universal language.
And what's it saying?
It's speaking to balance, efficiency, beauty even. Think about nature, flowers, right? The symmetry we see, it's not just to be pretty.
There's got to be a reason.
Right. It helps them attract those pollinators, which means survival of the species.
Wow, it's like form and function all rolled into one.
Exactly. And our own bodies.
Yep.
Right? 2 eyes, 2 arms, 2 legs. Bilateral symmetry lets us move and interact with the world in this balanced, coordinated way.
So it's not just about aesthetics then. It's about like functionality and survival too.
Absolutely. And that's huge in things like art, architecture, design. Artists have used symmetry for centuries to create balance, harmony in their work. Architects too, not just because it looks nice, but for structural stability. Those majestic arches in cathedrals, the columns in like Greek temples, all about symmetry.
You walk into those spaces and you can just feel it, that sense of balance, of grandeur even.
For sure. And it's not just old stuff either. Think about modern logos. A lot of them use symmetry to be memorable, easy to recognize. Apple, Mercedes-Benz, all symmetrical. It's like subliminal messaging.
Wow, I never thought about that. So symmetry is everywhere, this powerful force that shapes the world around us, even how we see things. And most of the time, we don't even realize it's happening.
Exactly. And the more you pay attention, the more you'll see it.
So for our listeners who are ready to ditch the geometry textbooks and take a walk in the park, how can they tap into this idea of symmetry in their own lives? What should they be looking for?
Here's a thought to go on. As you go about your day, right, just notice the shapes and patterns around you. In nature, buildings, everyday objects, look for that symmetry. And then think about how it makes you feel. Does a symmetrical design make you feel calmer, more at ease? Does something asymmetrical feel more dynamic, exciting even?
It's like we're all on a treasure hunt now, searching for hidden patterns, unlocking the secrets of symmetry. This deep dive, I'll tell you, it's really opened my eyes to a whole new way of seeing things. Hopefully our listeners feel the same way.